drones, cloud-based system for drones management over the internet. Please welcome Professor Koubaa from Prince Sultan University.
First of all, I would like to thank the organizer for inviting the Robotics and Internet of Things Lab and inviting us for the exhibition and for the conference. I'm very glad today to present our work about the Internet of Drones, and I could actually call it the Internet of Robots because it can be to the clouds and to the robots as well. First of all, I'm working as a full professor in Prince Sultan University. I'm leading the research lab on the robotics and Internet of Things, and we work on mainly two main areas related to the Internet of Things and also to the robotics. And our objective is actually to integrate robots with the Internet and with the Internet of Things, and also with the cloud, to take more advantages of them, and I'm going to explain through this presentation the advantages of such an integration. We do also work on deep learning, and we apply it on aerial images for surveying, inspection, and semantic segmentations as well. So I would like also to announce that we have different openings in the lab for those who would be interested. We do have postdoc openings related to unmanned aerial systems, Internet of Things, deep learning, self-driving cars, or cyber-physical systems, and so on. We do also have positions for short-term internships for master students and for PhD students if they want to join for a couple of months, ranging from 1 month to 6 months. We can also look at this. Okay. So, as already mentioned, we work on different projects. I'm going first to give an overview about the activities of the Robotics and Internet of Things Lab. We work on the safety and security of Internet of Drones because we have almost completed from the functional part I'm going to present today. And now we are looking at the security and safety aspects. And for this, we have one PhD student working in Tunisia in collaboration with the University of Carthage. We work also in aerial image analysis using deep learning and semantic segmentation. We do have also a project with M company and Machines Talk about the Internet of Things project, mainly the smart palm, monitoring palms over the internet. We work also on transforming the Prince Sultan University into a smart campus in collaboration with Machines Talk. And we have some work with Sister Research Center in Portugal in what concerns real-time performance evaluation of the 15.4 Internet of Things protocol. And we work also with multi-drone collaboration as well. So why the Internet of Drones, why the Internet of Robots? So we usually talk the drones can actually help in disaster management, in many applications, in surveillance and so on. And imagine now there is a certain disaster and we want actually to make inspection with the drone. So in this case, what we have to do, the policemen or the officers have to take the drone in their cars and move close to the area and then send the drone. They have to teleoperate it with like a line of sight. So this is kind of cumbersome. It's not an automated process. I think that the future, we need to control everything, the robots and the drones, through the internet. And I think soon or late is going to come. So the best scenario would be that we have drones or robots deployed in some places, for example, in the roof of the buildings and so on. And whenever there is an event, whatever it is a disaster, whether it is traffic transport, smart transport, or traffic monitoring and so on, we can just control the drone over the internet, send them to the location of preference, and monitor them in real time, and applying any rules that we want on the drone in the real time. Okay, so this is one of the applications, for example, traffic management. Okay, if we want to go, for example, to the intersection, count the number of cars, and so on, we can send the drones, but it's now the current use is that we need to be very close to the area, and we control the drones using remote control or using direct communication. But doing that through the internet and automating the process is going to bring a lot of advantages. But of course, there are a lot of challenges because we need to make sure about the communication quality, about the reliability of the communication infrastructure of the network and so on. So yeah, this is the example of disaster management. We did also some work around this for optimizing the collaborative work of drones in order to find people and rescue them. So the strategy is actually the integration of drones and robots over the internet. And this actually, the idea started a couple of years ago when I was working on the development of a mobile robot for office environments. And in that time, when we deployed the robot, actually we used like a local area network. We developed the robot using ROS. And in ROS, usually you are confined to a local area network. So the communication ways was very small. So in this case, we can only navigate within like a certain range of maybe 10 meters or 20 meters, depending on the Wi-Fi communication rate. So at that time, I was thinking, how can we control the robots to the internet? I would like just to put my robot anywhere, and I can just have a video stream coming from it. I can tell you of the robot, making the inspection and so on. So we have browsed several like approaches that were developed in the internet. And so imagine that you have an environment like this and you use a Wi-Fi network. This is actually the PSU map, the first floor of CCS department. And with Wi-Fi, you can only use a small range. Of course, you can use Wi-Fi extender, but in this case, you have to move from one Wi-Fi hotspot to another, and it's not actually very convenient. So cloud robotics was one of the solutions that we have investigated, and there has been a couple of works that was developed since 2011 or 2010. And the idea of cloud robotics is actually the integration of robots into the cloud through the internet. So the cloud will be kind of a mobile sensor and sending all the information in real time to the cloud to process them, taking advantage of the cloud resources, and then the cloud can take the actions and send back to the robot. So the term of cloud robotics was defined by Koubaa in 2010 in this paper, and it was to actually take benefit of the cloud resource for parallel computation and enhancing the resource computation of the robot. And we can see that cloud robotics from two perspectives. Virtualization of robotic system, it means we can seamlessly access the robot anywhere and through any interface. And the second usage of cloud robotics is to offload computation. Now imagine that you have heavy image processing to do it. You can do it on board, but in this case you need to have GPU processing. It's going to consume much more faster your battery in this case, so it's not going to be energy efficient. So instead of doing this, now there is a big trend to try to offload the computation from the robot into the cloud. So the massive computation will be done in the cloud. For example, you can run deep learning algorithms in the cloud. In this case, you just need to send your the stream to the cloud, and then the cloud is going to tell you what's in the image and then send back you the information. There was a couple of proposals, like the Earth project. This is a European project that has developed a cloud engine to promote the collaboration between the robots. And also one of the pioneer works is actually the ROSLink and the ROSGS. So ROSBridge, it allows to access the robot using a web browser. It's something good, but what's the problem with ROSGS? The server must be located inside the robot. So in this case, you need to be inside the same network of the robot, and this is not pretty much convenient. So our idea is actually, this is actually the different works that were proposed around cloud robotics, and our idea was actually to use a three-tier architecture, as I'm going to explain, not putting the server inside the robot, but putting it into the cloud, and then the robot needs to connect with the cloud, and the user needs to connect to the cloud, and the cloud is going to act as a proxy between both ends. Okay, so the objective is to connect the drones and the robot to the internet, access them virtually, and also offload the computation and take benefit of the cloud resources. There are two approaches for communicating with between robots and the ground station. So we can use the MAVLink protocol. This is already like a standard for unmanned aerial systems communication. And we have developed our own protocol that is called the ROSLink, which actually is inspired from the MAVLink and allows to connect any ROS-enabled robot to the internet. So MAVLink is basically message serialization, that is binary message serialization that allows to exchange information between a drone or any unmanned system. It can be also a ground robot and a ground station here. So, and it contains information like about the latitude, the longitude, the altitude, and different kind of things. Of course, you can. There are different interfaces that allows you to monitor the drone over the internet using the MAVLink protocol. And from our side, we have developed the ROSLink protocol, okay, that uses this kind of architecture. So here we have a proxy. This is our cloud server. We're going to have the ROSLink proxy, and any robot which works with ROS, we will define for it a ROSLink bridge that is going to read all the information coming from ROS and send them to the cloud. Now, any user who would like to control the robot or monitor the robot, he will also connect to the cloud. Okay, of course, every robot has an ID, so the cloud can identify the robot and the user through their IDs and then make them communicate with each other. This is the message structure of the ROSLink protocol. Of course, we do have a paper if you want to read more about the details. So we come up to the Dronemap. So Dronemap, this is the cloud-based system that we have developed. It allows actually to communicate between the drone or the robot using 3 4G connections and a ground station, a web ground station, or a mobile application ground station through the cloud. This is basically the architecture, and we have developed a complete software from scratch, okay, that allows to make the communication. So we have developed a MAV proxy and ROSLink proxy. This one, it communicates through the MAVLink interface, and this proxy communicates through the ROSLink interface. And we do have network using UDP sockets, and we have also used WebSockets. So for reliability, we have dual channels. We can use either WebSockets or UDP for communication. And for video streaming, we need to use WebSockets because it's more reliable and more appropriate for the communication. So the problem with the ROS that we have solved is that usually when you start a robot, you need to have a ROS master. Okay, this is something known for anyone who's working in ROS. So if you have 3 robots, everyone is going to have his own ROS, and every user has to connect to the ROS master here. But if we have multi-robot system, one of the solutions is to make only one ROS master. This solution is possible, but it's not scalable because it's going to have more difficult management of the robots using only one ROS master, and it has a single point of failure because if the ROS master fails, everything is going to be broken. So in this case, we have developed the ROSLink cloud proxy that I have explained, and the idea here is actually to create this ROSLink bridge that allows the communication between multiple users and multiple robots at the same time. We made also performance evaluation to see the impact of the networking, because now the network comes into play, and if the network is not good, probably or certainly the communication is not going to be smooth between the robot and the user. And here we can see actually the impact of different network configurations. This is when running on a single computer, and this is when running on a bad communication. So you can see in bad communication we have a big jitter and a big variation of the delay. So just let me, before continuing the presentation, I would like to show you a live demo. So now we have a robot that is now here in the exhibition room, and now I'm connected into a different network. The other robot is connected to a different network, so virtually we don't have. So now I'm able to check which robots are connected to my cloud system. I have a public server to which this application is now connected, and my robot that is in the exhibition center is connected through 4G. Now I can access the information. I can see in real time the video stream coming from the robot. And they can even manipulate the robot, so I will make it turn here if I want to check. So I can see, okay. So everything now is based through the internet. You can see, we have almost maybe a couple of milliseconds of delay, hundreds of milliseconds. But now I think the future is with the 5G communication, because most of the people say, okay, what about the communication quality? What about the reliability and so on? Of course, now with 4G, we might have a good communication quality, but in the future, maybe 3 or 4 years later, we're going to have 5G, which can guarantee less than 100 milliseconds of delay and provide you very high bandwidth. So this kind of application is going to be like very straightforward with no problems at all. And even with 4G, it's quite satisfactory. So at least you can manipulate your robot, you can send it to navigation, and we can also send an autonomous mission from here while monitoring the robot remotely. Okay, so we have also developed web application. We can see the list of drones or robots connected. We have another web application that this is for outdoor drones. You can see on Google Maps, you have all the information about the drone, the altitude, the airspeed. You can send autonomous mission, you can define waypoints to visit. Everything can be done through the internet, and it works pretty much perfectly. So to evaluate the performance of the approach, we have tested a tracking application, GPS tracking application. And the idea here is that we have a user with a mobile phone that is going to send its GPS locations to the cloud, and the cloud is going to send the GPS location to the drone, and the drone has to monitor has to follow the working person. And we have investigated this scenario under different conditions. So this is the mobile application that we have developed, and this is actually the scenario for the communication between the robots and the drone. I have here a video. I don't know if I can. You can find it. I can share with you the paper and the video. So we did this real experiment with the real drone. This is the football field of PSU, and we have measured the gap or the distance gap between the drone and the robot. So you can see now, this is now when the starting point, the drone was at 20 meters, and then we waited the drone until it comes at the same location of the person, and the person starts moving here at slow speed until, okay, so here it starts to run. Okay, you see when it runs, the gap actually is going to increase, and this is due to the latency of the network. There are a lot of factors because we have used the Wi-Fi router. It's a small Wi-Fi router. It's actually not of high quality, and the communication here it makes a difference. We did a lot of other experiments with reliable network, with non-reliable networks, using a working person and also using a moving car. We also investigated the impact of acceleration of the car with respect to the following distance. And you can see a lot of examples. So using the car, the gap can be actually very big due to the difference of latency and also to the network communication as well. So all of this, we have a lot of demos with real drones that you can look at. I can share with you later on if you have interest. Okay, so that's pretty much all. And if you have any questions, you can respond to them in the question session. Thank you very much.
I'd like to thank Professor Koubaa for his exciting presentation on drone management using clouds. Now it's time for the next presentation, in which by Dr. Khalil Ahmed Yusuf. He's Assistant Professor at